also. If I ask you, is there any real number exactly 1 less than its cube? Can you come up with an equation for this? Any real number, and let the real number be x. Can you translate this sentence into an equation? X is exactly 1 less than its cube. What is the right side? X cubed minus 1. I'm asking you, does this equation has a solution? Does this has a solution? Usually IVT, we can use that to find the solution within 2 numbers. That's what we can. We don't necessarily can find the solution by using IVT, but we can narrow in. Okay, the solution will be in this interval. Does it make sense? So I can change that to x cubed minus x minus 1 equal to 0. And that is the same thing as asking you, does this equation has a solution? You follow? If I change that to a function, I'm going to call the function f is x cubed minus x minus 1. So I can ask you, can you guarantee that function f has a root, has a 0 somewhere? So, you see this function here? Right? I'm looking for 0. So your strategy will be, if you can find 2 values, when you sub in A is negative, sub in B is positive, then go from negative to positive, don't you need to pass 0? Right? You always have to pass 0 when you go from negative to positive or positive to negative. Alright, we can try it. Let's see f of 0. What is f of 0? Negative 1, right? What is f of 1? It's still negative 1. Okay, what is f of 2? That's 8 minus 2 minus 1. That's 5, isn't it? You see, the y value go from negative to positive. Don't I need to pass 0 somewhere here? And then, because you sub in 1 and 2, so your c value need to be within 1 and 2. So the IVT guarantee that there will be a c within 1, 2 that satisfy f of c is equal to 0. Why? Because 0 is between f of 2, a positive number, and the negative number. Yeah? So it could just be a simple question like this, and you can develop and use the IVT to prove it. Okay. Intermediate value here. And this is exactly what you just did. Does this have a 0 in this interval? See that? That's what you just did. Yeah. Okay. I'm going to go back to the one we skipped. Okay. Back to exploration 1. This is a little tricky. You're a advanced class, right? You calculus AB, you're all mega star, good in math, or very interested in math. Yes?
I don't know how it's
Sure. It says this is function f of x. Can we remove a discontinuity? Removable must be a what type of discontinuity? It must be a hole. If I want to remove a hole, if this function has a hole, the only way to remove it is to assign a point exactly the same location as the hole. Patch it, right? Patch it. If this is at A and this y value is at K, I will assign AK into the function to make it continuous. So your goal is to find where the hole is location is. First step, we know the hole in a rational function is a factor that can be canceled. So our first step is to factor the denominator. Plus 3 minus 3. There are two possibilities, right? It's possible that my hole is at x equals 2. And where are the possibilities? Negative 3 or 3. One of those. If I can just factor the top, that will be beautiful. Can anybody factor that for me? It's really hard, isn't it? It's not quadratic. It's like mission impossible. I don't know if I can factor that. I cannot either. How do I know if x plus 3 is a factor of that? Any way to check? We are a problem solver, right? One way doesn't work, we use another way. How do I know if x plus 3 is a factor? Or is it x minus 3? How do I check? Division. Yeah, I can use division. Or I can substitute that in. If I put in x equals to negative 3 into this, if this is a factor, then okay, I can use division. Because you say, is 11 the factor of 3? Right? If you divide 11 divided by 3, 2, 6, 3, 9. If you have any remainder, that means it's not a factor. 12 divided by 3. If the remainder is 0, then 3 is the factor. Okay, so we are going to divide. Which one do you want to try? Jocelyn, you choose. Should I use x plus 3 or x minus 3?
X plus 3.
Okay, let's do that. X plus 3. Do you know how to do long division? Okay, what is on top? X squared. X squared times x is x cubed plus 3x squared. Subtract. Okay, negative 3x squared. So I need to times negative 3x, right? Multiply. And then minus 9x. Am I right? 9x. So I got negative 16x. Am I doing something wrong? Oh, right here. Yeah, that's right. Yes, 9, okay? So looks like this one is not gonna work. I feel like I'm doing something wrong. Can somebody catch it? X cubed plus 3x, right? And then you subtract. Put down the negative 7 minus 3x minus, oh yeah, this is, sorry, negative 7 minus negative 9 is what? 2x. No wonder. That looks wrong. Okay, then plus 2. So 2x plus 6. Do I have a remainder? Negative 6 minus 6 is negative 12. I have a remainder. So that's not the factor. Let's try the other one. I'm gonna try synthetic division this time. So I'm gonna sub in 3. So put down 1, multiply by 3, I'm adding 9, I'm adding, oh, my remainder is 0. Excellent. That means this is a factor. So that will be equal to x minus 3. This is the other part. Okay, I think we just found the hole. Where is it? Where is it? 3. Can you find the y value? We did this on limits. How do you find the limit of the hole? At the beginning, we cannot sub in x equal to 3, right? That's why you factor and cancel, then you substitute that 3 into the remaining part of it. So let's find it. That is 9 plus 2 divided by the remaining part is 6. 18 plus 2 is 6. 20 over 6. 10 over 3. 10 over 3 is where the hole is. Yeah? So okay, so how do we remove a discontinuity? F of x has a hole, but I'm going to create another function g of x where I fix it. I can write a piecewise function. So I'm going to say g of x is this, x squared minus 9. What's the domain of this? X cannot be equal to
0. Wait, no.
what value of x is making denominator 0? What is the value? Cannot be what? 3 or negative 3. Yeah, anywhere else will be continuous. But I'm going to assign the value of g when x equals to 3. What is the y value? Do you see that g of x has no hole? Because I patched it, I fixed it, I assigned that point back into the function. So now there's no hole. It might still have the vertical asymptote, but no hole. Okay, and we remove that discontinuity. Today we cover a lot, but I want you to be a master of justifying when can you use IVT to prove when a solution exists. Okay, so let's work on that. I will post the notes on OneNote and start